Hello everyone, welcome to another video on techniques of integration. In this video I'll be looking at Z substitution as a technique of integration. So let's start then. We have the question here that says evaluate the integral of 1 over 1 plus sine x plus cos x dx. Now like I said, we're going to use Z substitution, so let's start then. So capturing the question, we have the integral of 1 all over 1 plus sine x plus cos x and dx. Now this substitution, I spoke about it in the previous video. Let me just remind you, the essence of this substitution is to let tan of, in this case the variable is x, so we're saying x over 2 be equal to z. Now looking at the right angle triangle where we define this angle x over 2, we have the following. So this is our angle x over 2, and therefore if tangent of this angle is z, it means we have z opposite adjacent has to be 1, because remember z can be written as z over 1, which will be equal to the opposite side over the adjacent side by definition of tangent. Right, by Pythagoras theorem you'll agree with me that the hypotenuse has to be the square root, the positive square root of 1 plus z squared. We square that, add them and take square root. That will be the hypotenuse. Now, three results to obtain from this one. The first result is to look at sine of x by using double angle formula. This is 2 sine x times cosine of x. Let's punch in the information we have. 2, what is sine x? Sine x is the opposite over hypotenuse. So we're saying times z all over square root of 1 plus z squared times, what is cosine? Adjacent over hypotenuse. 1 all over square root of 1 plus z squared. Now simplifying this, you'll agree with me that what we have is 2 times z times 1 is 2z. In the denominator, this times that, remember this is square root of 1 plus z squared times square root of 1 plus z squared is basically square root of 1 plus z squared, or that squared. The answer just comes out as 1 plus z squared. So what we're saying here now is sine x changing from x to z, sine x is given by this expression here. Let me move on to talk about cosine of x. Remember here we have both sine and cosine. Talking about cosine of x, result, very important, result number 2, cosine of x. Let me rewrite this, cosine of x. We're looking at double angle formula, cosine, or come and fix x there. Cosine of x, according to double angle formula, remember cosine has 3 expressions. Double angle formula for cosine. Let me just show you here. We said in the previous video, I told you that cosine of 2 alpha is actually equal to cos squared of alpha minus sine squared of alpha, 2 cos squared of alpha minus 1, and then 1 minus 2 sine squared of alpha. Now I'm going to take this one. Remember, if you have x here, there it must be x over 2, because that angle must always be half of the angle there. So basically I'm saying cos x is going to be equal to 2 cos of cos squared of x over 2 minus 1. Let's punch in what we know. So this is going to be 2 times, what is cosine of x over 2? Adjacent of hypotenuse. So it's going to be 1 over square root of 1 plus z squared. Remember, we have to square this and then minus 1. So squaring this, you'll agree with me that the answer is just 2 times 1 over 1 plus z squared. Because squaring 1 is 1. Squaring square root of 1 plus z squared is just 1 plus z squared minus 1. Let's simplify this. Taking us to page 2. What do we have on page 2? Where we have the following. Simplifying that, we're going to have 2 times 1 obviously is 2 all over 1 plus z squared, and then minus 1, which we can rewrite as 2 all over 1 plus z squared minus 1 plus z squared in brackets like that over 1 plus z squared. Remember, this is 1, but I want to make the denominator the same, so we can say now 1 plus z squared. This 1 plus z squared into 1 plus z squared is 1 times 2. 1 times 2 minus this expression into that expression. The answer is 1 times the numerator, which is 1 plus z squared. What we have now is 2 minus 1 minus z squared all over 1 plus z squared, which simplifies to, if you agree with me, it simplifies to 1 minus z squared all over 1 plus z squared. So we are saying cosine of x is equal to this. Very serious result. We're left with 1, which is the transition from dx to dz. In order for us to move from dx to dz, we're going to use this equation here. We said let tan x over 2 equals z, and that one is what we're going to use. So now we are saying tan of x over 2 is equal to z. We're going to differentiate both sides. Remember this one now, we're using chain rule. Derivative of tangent is secant squared. Derivative of, so we're going to have derivative of tangent is secant squared of what? Of x over 2. And then we have to multiply this by derivative of x over 2. Remember, x over 2 is the same as half x. And half is a constant. And derivative of x with respect to x is 1. What is 1 times half? The answer is half. But remember, we have to say dx because we're on the left. And then on the right, we just have dz. Now, simplifying this up, we have sec squared of x over 2 dx. Multiply by 2 both sides. You are going to agree with me that we have 2 dz. Now, what is sec squared? Well, going back here, secant is going to be hypotenuse of adjacent. Now, secant, like I said, hypotenuse of adjacent, and we have to square that. So we're basically saying, taking us to page 3. Yep, you can see there. Okay, good. Taking us to page 3, we're basically saying, that square root of 1 plus z squared all over 1, that's secant of x over 2. It has to be squared, and then dx is equal to 2 dz. Simplifying this, you'll agree with me that the answer is just 1 plus z squared in brackets. Dx is equal to 2 dz. Solving for dx, we have dx is equal to 2 all over 1 plus z squared, and then d what? dz. So this is a critical result as well. So we have 3 results now, and therefore this integral here can be totally transformed into z instead of x as our variable, dummy variable. So this one here changes from sine x to, 2z over 1 plus z squared. Cosine x changes to 1 minus z squared over 1 plus z squared. And then dx changes to an expression underneath this page here. Dx changes to 2 over 1 plus z squared dz. So we are now saying basically, let me put this one in order now because we have all the results we need. So basically what I'm saying is, therefore, our integral now, 1 over 1 plus sine x plus cos x dx changes to the integral of 1 all over 1 plus sine x, remember 2z over 1 plus z squared, plus cos x, remember, is 1 minus z squared over 1 plus z squared, and dx, remember, is 2 over 1 plus z squared dz. Fantastic. Now we've moved totally from x to z as our variable of integration, the dummy variable. We have to simplify the denominator here now as follows. So if I may squeeze it in here, the integral of 1 all over. Now this part here, I'm gonna remember the denominator here is 1 plus z squared, there also 1 plus z squared. So I can rewrite 1 as 1 plus z squared all over 1 plus z squared, and then I have 2z over 1 plus z squared, and then I have plus 1 minus z squared over 1 plus z squared, and then times 2 over 1 plus z squared dz. Now let's simplify this part. Remember the denominator is the same, I just add numerators. Taking us to page 4. So what I have now is the following. So I'm basically saying that will be equal to the integral of 1 all over, in the denominator I have 1 plus z squared plus 2z minus plus 1 minus z squared all over 1 plus z squared, because the denominator is the same, so I just add numerators. What are we saying here? Times 2 all over 1 plus z squared times dz. This part here, simplifying what we have in the numerator, in the denominator, here we have, remember this cancels that, and we have 2 plus 2z, 2 plus 2z all over 1 plus z squared, and then we have to multiply this by 2 over 1 plus z squared dz. Now this part here, you'll agree with me that it's the integral of 1 plus z squared goes up all over 2 plus 2z times 2 all over 1 plus z squared dz. Notice that this cancels that. So what do we have now? Here in the numerator, we have 1 integral of 1 all over. Let me factorize this. 1 plus z times 2 dz. Now this 2 cancels that 2. So what I have now is the integral of 1 over 1 plus z dz. Now this, if you agree with me, we can actually use substitution now, but we know that this is just natural log of 1 plus z. By using substitution, we are going to say let 1 plus z be equal to u. And what does it mean? dz equals du. So it means where there is dz, I can put du, and then 1 over u. Remember, 1 plus z equals u. So this integral then changes to, if I may squeeze it in here, it will be the integral of 1 over u and du. If you agree with me, this is natural log of u plus a constant c. What is u? 1 plus z. So this is going to be, if you like, natural log of 1 plus z plus c. Now we just have to put our original variable. So we're moving from z back to our original variable. Let me just write it down here. So basically we are saying that our integral simplifies to the natural log of 1 plus, what is z? Well, to get the value of z, we move back to our page 1. Page 1 is somewhere here. There is our page 1. What does it say? Our z, the relationship between z and x is that z equals tan of x over 2. So now it means that this final result here will be natural log of 1 plus tan x over 2 and then plus c. All that in absolute value. Obviously 1 plus z has to be in absolute value. So this is that, and if you like, in brackets, the absolute value of this, natural log of the absolute value of this, plus our constant c. So what are we saying? We're saying therefore the integral of 1 all over 1 plus sine x plus cosine of x dx is basically equal to the natural log of 1, absolute value of 1 plus tan of x over 2 plus a constant c. This is how we evaluate these integrals by using z substitution. Looking very intimidating, but when we transform it from, like they say, the x world into the z world, you realize how easy it is. Works out very nicely like that. Right? I did promise that I was going to come up with many videos on z substitution. This is perhaps I would say the first one after the previous one. This is the first one of the promised integrals. I'll definitely have to come again with another integral, a little bit more challenging perhaps than this one. We want to make sure that the z substitution technique is well understood. Now, if you're new to this channel, do not forget to subscribe. Your comments, we truly appreciate your comments. All right, see you in the next one.